there. Are you wondering why I'm sitting here with all these lovely objects? Well, they all have one thing in common. They're all alloys. Just in case you don't know what those are, let's start with the basics. An alloy is made when two or more metallic elements are combined to make one compound. But why would anyone go to all that trouble? Aren't the basic elements that we find in nature good enough? No, they're not. A simple example of when alloys are necessary is the process of making a sword. When you make a sword, you want something that is strong enough to hold back the blows, bendy enough to absorb the force without breaking, and light enough to wave around easily. You also want it to last a long time, so when you are old and retire from battle, you can pass on your sacred mantle to your grandchild so they may honor your legacy. But it's very difficult, not to mention expensive, to find one material that does all those things. And that's where alloys come in. When compared to pure elements, alloys are often cheaper, can make the metals much stronger as they can balance the happy medium between, for example, being too brittle or too malleable, and it also makes metals more resistant to corrosion. For example, adding carbon atoms to iron makes the iron harder and prevents it from rusting. Who wouldn't want that? Who wouldn't want that? Of course, you have to be careful when you're making an alloy. If you add too much carbon, the iron can become so hard that it's brittle and breaks more easily. But there are different kinds of alloys too. The atoms of the two elements can combine in a substitutional or an interstitial way. Substitutional alloys exist when the atoms of the two elements are similar sizes. The atoms of one element just replace where the atoms of the other one is in the atomic structure, so the shape looks exactly the same. Interstitial alloys are made when the atoms of one element are much smaller than the other element. Here, the smaller elements just fill the gaps in the atomic structure of the larger atom, and the atomic structure looks much more compact. So where do we see alloys in our everyday lives? And why are these particular objects alloys? Hold your horses. I'll be answering all of these questions right now. We can see a great example of an alloy in the gold bracelet right here. Gold is very desirable for looking classy, but the metal itself is too soft to do anything with. We can alloy gold with other metals like zinc and cobalt to make the metal stronger. We can also alloy it with copper to get that beautiful rose gold that's so trendy right now. We can alloy iron with carbon to make steel, which makes it stronger, tougher, and more resistant to rust and wear. We can alloy copper with zinc, so pennies can be made at a much lower cost. Alloys are used in everything from jewelry to space shuttle construction. However, it's not just about melting two metals and throwing them together. Making alloys is a careful process. One might even call it a science. Let's take steel, for example. You might add varying amounts of carbon for different purposes, but if you add too much, the final product is brittle and difficult to work with. But if done right, alloys can be a valuable addition to all of our lives. Without alloys, the world would fall apart. Apart from being very useful in the practical world, alloys tell us an important story about how the chemical structures and intermolecular forces of a substance affect its macroscopic properties. Pure metals are malleable because when metal atoms bond, they share electrons all throughout the structure. When a non-metal, such as carbon, is added to the metal, it interferes with the sharing. That is why adding too much carbon to steel can make it too brittle. Is that it? So I hope I've taught you a little bit today about alloys and why items such as these are so important in our everyday lives. Signing off, Chemist Try. Bye-bye.
A good chemist knows the periodic table. Forever doing chemistry. Got my sing-along.
Woo! H is hydrogen. He, helium. Li, lithium.